Welcome back. In this video, I'm going to go over how to constrain your piston once you have it separated into its body and shaft parts. So I'm going to open the piston body and piston shaft. And when you're constraining a piston, it's very important that you make all of the constraints in the final assembly. If I were to make an assembly, constrain the pistons, and then import that assembly into a larger assembly, the pistons wouldn't work. They wouldn't be able to move. So you need to make all of the constraints in the final assembly. So I'm going to make an assembly for our pistons, which would also be the final assembly. And I'm going to add our shaft and body, unground that. And the first step of constraining pistons is always going into the body and taking this central piece right here and unchecking visibility. So now it's see-through. So what we want to do is we want to take this axis of the shaft and constrain it to this axis of the body, just like that. And in real life, obviously, this cylinder part of the shaft wouldn't be able to go past these two parts of the body, right? But in CAD, you can go straight through, and that messes up the stroke length. So we want to stop our shaft from going past this point right here, and stop it from going past this point right here. And the way you do that is with a constraint, and it is called a maximum and minimum constraint, which you can get by clicking this arrow right here. So you can, for pistons at least, you don't even have to use the maximum, you can do everything with a minimum constraint. So to demonstrate, I would have a mate, and I would select this face and this face, but I check minimum, and with a offset of 0. And when I click OK, you'll notice that they're not fully constrained, but it can't go past this point anymore. So that's what the minimum does. And I can do the exact same thing on the other side. And I don't even need to use the maximum constraint, just do it again with minimum, and there we go. Now our piston is accurately represents our stroke length. And as a side note, minimum and maximum constraints are also useful if you want to make two faces parallel, in which case you could do a flush with a minimum, and that would make two objects parallel to each other, though not touching. Anyway, we can go back into our piston body and return on our visibility. And now we have a completely working piston. And I did want to go over how you could mount this piston. This has rear pivot mounting, which we determined when we downloaded the piston. And we can use brackets for that to mount our piston to stock. So here I have some brackets, and just to show how we might constrain them to our piston, we could select that bracket, which corresponds to this side. And we can also go like that to that face right there. And we do the same thing with this bracket over here. Constrain the two faces. And now we have these brackets on the end of our piston. And now we can mount our piston to stock, for example. And that's just one way you might mount a piston. Keep in mind, not all pistons have this rear pivot mounting piece. But in any case, we have our working piston. The stroke length, I believe, is accurately 3 inches. And that is all. We're done.